Okay, so here we are going to decide the nature of the roots of this equation without actually solving it. Okay, so the first thing is to pop in our delta formula. So we're going to have delta is b squared minus 4ac, and that gives us 3 squared minus 4 times the 1 times 4. Okay, so this will give us 9 minus 16, which gives us negative 7. Okay, so while we're doing the easy ones, let me explain how I know that this then means that I have roots that are not real. So if we did solve this equation, okay, so let's pop it into the formula. So I'm going to go negative b plus or minus, well, I know what that is, b squared minus 4ac. We know that it's that, right? Over 2 times a, which is 1, so it's just 2. That would be my answer. And you can see that because the thing inside the surd sign is negative, it doesn't matter how many different ways I pop that into my calculator, I'm getting out a math error because it's not real. So I can already see that that is going to be something that is non-real. Okay, so I don't have roots. I can't go any further. I can't get a decimal for this. There are no real roots to this. Okay, so therefore I know. Okay, so I'm going to put here delta is negative. You may like to do that. You may want to write the words out. You may want to do both. Delta is negative. Now going back to the theory, which you need to learn off by heart, you need to know that when you've got a negative delta, your roots are non-real. And that is as far as you can go. There's nothing else to say about roots if they're non-real, because if they're not even real, they're not going to be rational or irrational or equal. There's nothing else to say. So that is the only thing that you need to say when you have an example where delta is negative. Okay, let's look at a different example. So what we do is we're asked for the nature of the roots. We pop down delta is b squared minus 4ac, and that gives us negative 5. Remember to include the negative when you're squaring, hey? Minus 4 times 1 times negative 6. Okay, so that gives us 25 there, positive 25, and negative times a negative gives me a positive, so that is plus that 24. Okay, so here I've got 49. 49 is a perfect square. We do need to be able to recognize that. Okay, so it's a perfect square. So delta is a perfect square. Delta is also positive. So let's just list these things here. Okay, it's a perfect square, it's positive. And so that means when it's a perfect square, you're going to have rational roots. Okay, so from there, your roots are rational. They're real because you've got something that is positive. But for them to be equal to each other, you need delta equals 0, which it's not. So we can also write down that it's unequal. There was no point in writing that down in the previous example because we weren't even dealing with rational or real roots. So there's nothing else to say really. But here we can qualify that they're unequal, rational, and real. Okay, then just to deepen your understanding again, if we had put that into the quadratic formula, okay, so we've got negative b, so 5, right, plus or minus the square root of b squared minus 4ac, which is this, okay, so I'm just going to put root 49 in there, okay, all over 2a, a is 1, so that would have been our answer, and then you could actually have done that, okay, because you could have gone 5 plus or minus, we know what that, we know that the root of 49 is 7, so 5 plus or minus 7 over 2, so that would have given us x equals 6, or x equals negative 1. So the roots are all of these things. They are rational numbers. They are real. but they're not equal. Okay, so we're doing a very shortened form of the quadratic formula, but I'm using my explanation on the right-hand side to help you understand how we get to being able to do this, and we're satisfied with our answer, and we know that we've got it. We've got the nature of the roots without actually having the roots themselves. You won't do this in your exercises. This is just part of the explanation of the easy ones so that you understand what is exactly happening. Okay, for this one, our b squared minus 4ac, which is delta, gives us 3 squared minus 4 times 2 times negative 7. Okay, so that gives me 9 plus 8 times 7, 56. Okay, so I've got 65. 65 is positive. Okay, which tells us that the roots are real. Okay, but unlike the previous example where we had 49, which gave us rational roots, this is going to give us something irrational, meaning if we do our sort to decimal button, you're going to end up with something that is a non-terminating, non-recurring decimal. So I know that delta is positive. Okay, so that means that my roots are real. Okay, but what they're not is they're not rational, and I'll prove it to you now, and they're definitely not equal. Okay, so again into the quadratic formulas, so we would have negative b, so negative 3 plus or minus the thing I've just worked out, right, all over 2a, which would have been 4. Okay, if you type that into the calculator, you're going to end up with x equals 1,265 whole and other numbers there, or x equals negative 2,765. We could approximate those on a parabola, but they're irrational. So there we go. They're not rational, they're not equal, but they are real. They actually do exist. So you can see that by doing the shortened form, I can make an assumption, because when I work it out fully, it does actually give me the same answer as it did if I just trusted those statements. Okay, this is the last easy example. So you've got delta is b squared minus 4ac again, okay, which gives me negative 6 all squared, right, minus 4 times 1 times 9. So here I've got 36 minus 36. 0. Great, that's the really sweet one that we've been looking for, because remember that if delta is 0, according to our theory, you have equal roots. So we will prove it. Okay, so this is now 0. It's obviously it's 0 or positive. We can consider it positive or equal to 0, so that works. So that means that we have roots that are real. And they're going to be rational because 0 is a perfect square. And they're going to be equal. Okay, let me prove it. So putting it into the quadratic formula, negative b would be negative 6, so it's positive 6, plus or minus the thing I just worked out, which is 0, right? All over 2a, which is 1, so it's 2. So here I've got 6 plus or minus 0, and you can see that when you're plus or minusing 0, then it doesn't make any difference whether it's plus or minus, because you're adding naught or you're subtracting naught. So here you've got 6 over 2, yeah, because I mean, what difference does it make? Which is 3. So x equals 3 or x equals 3. So they are equal roots. So now you can see the link between making statements about the nature of the roots and actually working out the roots, that these statements are completely logical. Okay, just a word on the way that the questions get asked here. These are obviously the simple ones. So it'll say show that the roots are real or rational or equal or whatever, and then you just do your delta thing and you get out the answer. But lucky for you, they said show that, which means you know you have an agenda, you know what you're trying to get to. So if you get it wrong, you know you've done, if you don't get what they want, you've done something wrong and you need to go back and change it. Okay, then they say discuss the nature of the roots. This will be one where they don't give you what they're looking for, and you just have to come out with your answers at the end, whether they're real or rational or non-real, and so on. Okay, then sometimes what they do is they put in another variable, so your normal equation with your x's in it, and then there's a random p or an m or a q or something in there, and they say if p is not equal to 0. You don't need to do anything special with that. You can just assume. And the same for the next one. Okay, you can make that assumption. But what they're doing is they're just qualifying the question and saying, look, we know it won't work out if p is 0. And in this case, we know it won't work out if p is not a real number, because they're putting in a variable without telling you what kind of number it is. And then they're telling you what kind of number it's not. So they're saying it has to be real. In this case, it's not 0. So you can just make those assumptions when you're doing the question.